4.3, extrema. So there are two main types of extrema. There are maxima and there are minima. In other words, there are largest values and smallest values. I'm using the plural here, as opposed to extremum, maximum, and minimum, which would be singular. I'm just using the plural here. So two types of extrema. There's large values and small values. Largest values and smallest values. And within the maxima and minima, there are two types within those. And that would be absolute and relative. The book uses the word local. Okay, so those are two terms for that, local or relative. Okay. Same thing for minima, absolute, minimums, and local or relative. Oops. Local or relative, it doesn't matter what you want to call them. Both mean the same thing. Extrema, okay? Local, relative, minima. So the definitions of these are somewhat cumbrous if we're very specific about the words we use. I'm going to use, say, layman's terms here, and we will call the absolute maximum of a function will be the largest value of the function over the entire domain. Okay. Another word for absolute is also global, because it looks at the function as a whole in totality over the entire domain and finds the largest value for it. Okay. All right, so that would be the same thing for the absolute or global minimums. Minima would be the smallest value. I'm just going to change one word. All right, smallest value of the function over the entire domain. Okay, so local or relative is a little more subtle. Local or relative looks at a subset of the domain, right? It's not a global picture of what's happening. It's a local or relative picture of what's happening at a certain part of the function. So a local maximum would be, again, in layman's terms, largest value of the function over an open interval which is a subset of the domain. So it's only looking at some small part of the domain, but it's an interval across the domain. It's not just random locations all across the domain that are disconnected from each other. It is, you might say, like a connected set of points across the domain. It's a single interval in the domain, and it has to be open as well for reasons I'll discuss momentarily. Okay? So the local minimum reads the same way, except I'm just going to replace the word largest with smallest. It's the exact same idea. I'm looking at a subset of the domain and not the entirety of the function. Smallest value of the function over an, again, open interval. It sounds a little unnecessary for it to be open, but you'll see why momentarily. Interval, which is a subset of the domain. In general, we'll be working mostly with the local relative extrema. But in this first section, there'll be a heavy concentration on absolute extrema. But from then on out, after 4.3, it'll be mostly looking at local and relative extrema.